Now, as we move into our last event of the day, I would like to welcome Laurence Moroney to the stage for his presentation on what's new and exciting in the world of TensorFlow.
Well, hi, everybody, and thank you for that welcome, and I hope you're enjoying your day so far. So I'm Laurence. I lead AI advocacy here at Google, and I'm based in the Seattle area, so it's lunchtime for me, even though it's the end of the day for you, but I hope you're having a good day. So I'm here to talk about TensorFlow and kind of give a state of the union for where we're at with TensorFlow. And one of the things that we've been doing with TensorFlow over the last 12 months or last 18 months is that we generally have like twice a year, we do conferences around TensorFlow to announce what's latest and greatest. But of course, the COVID outbreak has made that a little bit difficult. So we've been doing like some online conferences, including me visiting you at this one, to talk about like what's some of the latest things and what's really the state of the union around TensorFlow and what we're doing. And one of the things that we found is that in times like this, when it's difficult because of the pandemic, we often turn to technology to make our lives better. And we've been investing very deeply in TensorFlow and in growing TensorFlow globally because of the ability with TensorFlow to build solutions that will make people's lives better. And there's a whole bunch of them. There's a few of them I thumbnailed here. I would say if you go to our YouTube channel, it's just youtube.com/TensorFlow, you can see some of these in more detail, but some of the stuff that's actually happening in the world of machine learning and AI being enabled by TensorFlow is really cool. So as for the size of our community, we're seeing the growth is just going off the charts. So we've had 200 million plus downloads of TensorFlow, and last summer, for the first time, we had months where we were getting over 10 million downloads each month. We've been building out guides and views for people to learn it, and we're 50 million plus views and reads of them. We have a blog that's approaching 9 million articles read now, and the YouTube channel, this is a little out of date, the YouTube channel has actually crossed over 10 million views now. For me personally, most exciting are the number of people who are learning TensorFlow, who are taking courses, taking online MOOCs and that kind of thing, and that number is actually approaching 1 million at the moment. And this is, in my belief, is the way that AI can be democratized and AI can be a force for good, is if the more people who know about it, who know how to do it, and not just hear about it, but are actually rolling their sleeves up and able to build solutions using it, then I think we can make the world a better place with it. So actually, I'll give a little demo of it. I like to do that as I'm doing my slides here, and I have some auto captions that I will turn on. And these auto captions you'll see are actually following my voice, and these are using TensorFlow in the back end, where we've built a system for automatic dictation, and you can see it works pretty well. And I often joke that the second longest word in the English language is the word anti-disestablishmentarianism, and you can see it even picked that up. And if you look really closely, if I say it again, it actually completes the word before I complete the word, because at one point in the middle of the word, there's only one word that will actually be a correct word after that point. So when I say it, the computer recognizes that's what I'm going to say. So I'll just say it again, anti-disestablishment. Now you see I didn't actually finish the word, but the computer did. So this is the kind of thing in the case of like to improve accessibility, for example, is to have auto captions like this. I find it's really cool. And this is freely available to anybody who's using Google Slides. So the TensorFlow architecture, the TensorFlow ecosystem itself, I like to look at it like this. There's really broken into two areas. One is around training and building models, and that's what the bread and butter of machine learning has been for, since machine learning was born. But if we really want to get models into people's hands, if we really want to use them to build applications that the average person will use, we need to be able to deploy those models onto the platforms that the average person uses. And that's mobile devices, your Android phone, your iOS phone. It's a web browser. It's being able to put it onto servers or in the cloud so that people can access them via their browser also. So we've been carefully designing the TensorFlow ecosystem around that principle. So on the left-hand side of the diagram here are all the things that we've been shipping to help you build models, help you train models. Things like Keras, you're probably familiar with, is a high-level API that allows you to design neural networks quite simply. That high-level API has sequential models for learners and for like the basic scenarios, but also what we call a functional API if you want to build more exotic models like GANs and that kind of thing. One of the things that we found is core for people who want to build models is really understanding the data. We did a lot of an analysis in the coding practices of people building models, and often you write this much code for the model, but you write this much code for handling the data, downloading it, cleaning it, pre-processing it, turning it into feature columns, one-hot encoding it, all of those kind of things. So we've been hard at work in a set of data set-based APIs that not only give you common data sets that you can access with a single line of code, but also the ability to slice and dice those data sets the way that you want to make it easier for you to get them into your model to train, to greatly lower your overall engineering costs. So you're not going to be messing around with the data, not spending too much time messing around with the data. You can focus on your solution instead. And then the other thing that we heard a lot about, and the most recent investments I'll be talking about a few slides down, are really around distributed training. So that as you want to learn, or if you want to train bigger and more complex models, a single CPU or a single GPU often isn't enough, and you need to be able to span multiple machines. And we'll talk a little bit about how you can do that. And then, of course, over on the right-hand side are the things for deploying and delivering your models. So TensorFlow Serving allows you to host it on a server with a REST API. So the idea is that somebody can call that REST API, the server will invoke the model to do the inference, and then the results will be delivered to the user. Or if you want the model closer to the user for privacy reasons, or if you don't want data like to have a round trip, then you can actually deploy it on device with something called TensorFlow Lite. We'll put it in Android or iOS, and now increasingly on embedded systems and on edge devices. And then, of course, if you want the model to actually execute in the browser, rather than the browser being used to call a server where the server would execute it, we actually have TensorFlow.js now, which allows you to invoke models using JavaScript. And you can even train models in the browser using JavaScript. So there's a whole lot going on there. So our ecosystem, we've really been driving for the last 2 years plus around TensorFlow 2.0 and 2.x, where with the initial release of 2.0, if you're not familiar with the history of it, when TensorFlow 1 was released, it was primarily coming out of our research org. And I like to see it as it was a research product aimed at researchers. The programming APIs weren't the kind of ways that a typical Python developer would do things. It was called what we call graph-oriented. And if you're not familiar with the quick description of that would be, you don't do line-by-line debugging of your code. You would write a ton of code to load something into a graph, and then you would execute that graph. And then when it went wrong, you try to figure out where that was. In Python, there's something called eager execution, and we really wanted to invest in that. So with TensorFlow 2.0, we had eager execution by default, and that's what you'd expect for typical programming, where you can do line-by-line debugging so you can see what's going on. And so with TensorFlow 2.0, we really launched that with the idea of growing the developer ecosystem greatly. And the numbers that I showed earlier on came as a result of that. We've been growing it, as you can see, through 2.1 through to our most recent release is 2.4. And our goal with the versions, particularly 2.1 and 2.3, was to really help you with the distributed training part of it, as well as continued performance improvements. So with 2.4, just to dig into that a little bit, I'd like to talk a little bit, first of all, about distributed training. So the idea behind training a model is it's basically you're doing a lot of pattern matching. It's very computationally intensive. Now, we discovered over time as an industry that all computers have a CPU, and CPU is a general purpose chip that can be used for anything. It's not particularly optimized for mathematics. It's not particularly optimized for the type of math that's involved when a computer is learning. But by an amazing cosmic coincidence, GPUs, which were originally invented for gaming, are optimized with lots of little cores that can handle matrix multiplication and can handle floating point multiplication. And as a result, they were wonderful for machine learning because a lot of the heavy duty math in that is matrix multiplication and floating point multiplication. And as a result, the availability of GPUs led to an explosion in machine learning. Now, a single GPU may not be enough for very complex models. And that's the first thing. So the idea behind that one is like we wanted to build APIs that would allow you to distribute your training. And ultimately, that means you're going to shard your data across multiple GPUs. You're going to train on subsets of the data across these multiple GPUs. And then the weights of your neural network will be different across the different GPUs. So at some point, you need to bring all of that back together and then rinse and repeat as you go through your learning cycle. And that's the idea behind a distribution strategy. It's not as simple as just slicing your data up, training it in multiple ones, and declaring victory. So the idea is then if you have like a number of GPUs and you want to distribute your training across them, we want to reduce the coding burden on you. But then a new type of chip also emerged called a TPU, and that's a tensor processing unit. And the idea behind the TPU was that what if we designed a chip that was optimized for machine learning? So it uses a reduced data set, a reduced data size, as well as it invests heavily on multiple cores and matrix multiplication and floating point multiplication that I was talking about earlier on, so that you can really focus on so you can really focus on machine learning with a chip that's dedicated for that. And that's the idea behind the TPU. Now, most TPUs have multiple cores within them. If you use a product called Google Colab, which you can freely access in your browser, just Google for it and you'll see it, you can actually train on a TPU using Google Colab, and the Colab version has 8 cores, and you need to do a distributed training across those 8 cores. And as a result, having a good distribution strategy for your training to take advantage of all of those cores that you have available will give you much faster training of your models. So as a result, we've been investing very heavily in that in TensorFlow 2.4, and we're continuing to improve that as we drive forward to TensorFlow 2.5. So the overall ecosystem, the vision that we have for it and the way that we like to drive it is really, we think about machine learning, AI, deep learning, all of these things as part of an ecosystem that's going from research to production that will be deployed everywhere, but still empowers responsible AI. And this has been the way that we've been designing the product as well as communicating the product. And I'd like to talk a little bit about each of these columns. So first of all is research. So we've been doing obviously heavy research ourselves into AI and into techniques with AI to drive AI forward, but also into solutions with AI. So for example, on the left here, there's a real-time sign language detection model, which was built using TensorFlow, and it's a combination of multiple existing models such as PoseNet, but they've been enhanced for this specific scenario for real-time sign language detection. With reinforcement learning, we've been investing heavily in that to make it better and more efficient. And a lot of the research that we've been doing there is finding its way into the product platform so that you can take advantage of it. And then also to really push forward at the bleeding edge is quantum computing. And so we've been investing in having TensorFlow as a tool that can be used in quantum scenarios. So for example, the paper that you can see on the right here was a reinforcement learning using quantum variational circuits. And if you have access to quantum computers, you can actually use a version of TensorFlow that was designed for quantum. So you could do your machine learning on quantum. And if you go to our site, TensorFlow.org/quantum, you'll see you can actually simulate quantum, and you can simulate showing how machines can learn in a quantum environment. If you don't actually have access, as most of us don't, to a quantum computer at the moment. And as a result, all of this kind of research has led to lots of add-ons and lots of extensions into our ecosystem. There's a bunch of them on the left here. The one that I'm particularly excited about is the 3D graphics, as you can see in this chart that's rotating, where instead of most computer vision is based on flat images and being able to extract features from those images, we've been doing a lot of research into depth images and seeing how to extract features out of depth images. So you can see the application of that in things like self-driving cars, where instead of taking a picture and trying to like interpolate, is this a pedestrian, is this a red traffic light, is this a whatever, from a flat picture, what if you can do that with depth analysis as well? So maybe you can have a better estimate of the distance between you and an object. Or just if you're doing feature extraction, features look different in 3D than they look in 2D, and as a result, the real world is in 3D, and you might get better and more sensitive feature extraction so that you can identify images more accurately. So those kind of things have been coming out of research, and we've been productizing them. A couple of the most recent ones have been the object detection API. So object detection is pretty complex in that it generally requires a multi-output model. One part of the model outputs the label about what you're seeing. Another output of the model outputs the bounding box. And as a result, coding for these and creating these yourself can be computationally intensive and can require lots and lots of coding. So we've been trying to reduce the amount of coding for that by having an API that's available for you. And the object detection API came out as a result of that. We're still working on it, but using the object detection API and transfer learning One thing that I teach in my Coursera course, I give an example of where with as few as 5 or 6 images, you can actually train something to recognize objects in the image. And if you take my Coursera courses, we actually build a zombie detector. So you can detect where zombies are in an image, trained on only 5 images of a zombie using this API. There's also TF recommenders. And so if you're probably familiar with recommendation engines, anytime you've done online shopping, you will have seen them. And a lot of the research that we've done into good recommenders, we've been productizing as part of this TF recommenders API. And it was released here at this URL. You can go check it out, tensorflow.org/recommenders. So that was research. Then the next thing is going to production and taking a machine learning to production. There's a lot of things that you need to do in that. So one new thing that has come out that we've learned is that people want to use the cloud. Now, earlier I mentioned using distributed training across multiple chips, be they GPUs or TPUs. But one thing is that also to be able to offload your training to a cloud server where it might have access to the hardware that you don't have access to on your development box. So if you're using Google Cloud Platform, for example, you might be able to rent a virtual machine that has a lot more memory, that has access to multiple GPUs, that has a faster CPU than you may have on your developer box. So we've heard from people that they want to be able to code and then outsource the training to those. And that's what TensorFlow Cloud is all about. So the goal of that is, if you can see here, if you're familiar with this code, this is a common data set called MNIST for handwriting digit recognition. And this is a simple sequential neural network. You can see it's a 3-layer neural network for recognizing those. This kind of code is like almost the hello world of doing deep learning. So if you wanted to train this on your local machine, you could do it just by running that code. But if you look at the cell at the bottom where we say tfc.run Docker image, the bucket name equals GCP bucket, that's like with a single line of code, you can now take this neural network and all of its dependencies, send it up to the cloud and do your training there. You probably wouldn't want to do it for MNIST because it's a pretty simple model that you can just train in a few seconds, but consider what that would look like for a more complex model. And the nice thing about cloud is you got elastic scalability and elastic charging, so you only pay for the capacity that you use. And so you could afford to use a supercomputer with more GPU, with more memory, with like a better CPU than you might have in your developer box, but only use it for the period that you're training on. That's the goal behind TensorFlow Cloud, to help you move to production more quickly. And then I mentioned earlier on TPUs, TensorFlow 2x supports TPUs. I spoke through them, and TPU infrastructure is available on the TPU infrastructure is available on the Google Cloud Platform. But you can also freely access them using Google Colab if you want to kick the tires. So now to deploy your stuff and being able to deploy it everywhere. So TensorFlow Lite, the goal behind that is to give you a runtime and a set of tools that will allow you to execute your models directly on people's devices. Now, the key to that, of course, is lower latency. So the model is on the device. So the round trip to the model is just on the device itself. Your data never leaves your server, which of course maintains privacy, and you don't need network connectivity. Earlier, I showed some pictures of some samples out in the wild, and one of them, if you go to the channel and take a look at, was used by rural farmers in Tanzania for detecting crop disease, and they were able to do that using a cheap Android phone, and they didn't have any kind of cloud connectivity on that phone or anything like that. Everything was encapsulated on the device so that they would get instant results, and they could do it, like I said, very, very inexpensively. So we've been investing really heavily in technology to shrink your models, to run them on phones or on edge devices without a loss in speed and or in accuracy. And so the tools to do that, as well as the runtime for that, on multiple platforms. And that's the idea behind TensorFlow Lite. TensorFlow.js I mentioned already for training and deploying ML models in the browser. And if you check out our channel, there's some really fun things that people have done by having TensorFlow.js in the browser and like maybe integrating that with a webcam in the browser. And the top left one here, for example, the Mona Lisa effect is pretty cool in the sense of there's that urban legend that when you go see the Mona Lisa, no matter where you are in the room, she's looking at you. So the developer of this just really leaned into that, and she built a model that would read the webcam and read your location on the webcam. So if I move to the left of my cam, or if I move to the right of my cam, it would detect where I am in the frame, and then the Mona Lisa image would turn its head to follow you. It's really spooky, but it's really fun when you see it in action. And just to show that's the kind of power of what can be done using machine learning in the browser. It's a gratuitous demo, but it's really fun. And it's like, think about how if you were to write a bunch of if-then code to do something like that, not if-then code, if-then code, there you go. And if you were to try and do that with that type of code, how difficult that would be. But with machine learning, it's pretty straightforward and simple. So we've been using this ourselves. So if you've used, for example, the Pixel device, one of my favorite features on that one is the Hold for Me, where it's basically a virtual assistant that will take your calls for you, will listen to what the person has to say, will turn that into a transcribed message, like the one you're seeing at the top of the screen here as I speak, and then you can decide whether you want to answer the phone or not by reading the message, and you're not actually talking to that person. And since I've been using that on my Pixel phone, the number of spam calls that I get has approached almost to zero. It's really cool. As well as things such as like OCR translation and being able to upscale pictures to things like HDR+. All of this is being done with on-device ML using TensorFlow Lite. And so, we're using it ourselves, I guess, is the point that I'm trying to make here. And that's how much we believe in the technology. TensorFlow Lite, we've been working really hard to improve that. And it's one of the biggest investments I think we're making this year. It's one of the things I'm spending maybe 80% of my time on is, making sure that TensorFlow Lite is the best possible product for developers. And our engineering team, as you can see, have been doing a lot of work on there. I'll call out a couple of them. If you're familiar with machine learning, particularly in natural language processing, there is a layer type called an LSTM. LSTMs are pretty sophisticated layers. There's a lot going on inside of them. And being able to convert a model that uses LSTMs to be battery friendly and memory friendly to work on a device has been quite the challenge. But that's one of the things that we've really, really invested deeply in. And we're kind of, with LSTM quantization, as you can see in the third column here, we're getting really excited about the possibilities of that. That models are getting smaller and smaller, using less and less battery, but also maintaining accuracy or maintaining close accuracy to what you'd be getting like when a model is running on a supercomputer. Then another very, very important thing, of course, is making sure that our AI is responsible. And we want to drive best practices to the world around, if you're building AI systems, what are the best ways that you can do to make sure that your AI is responsible? So often the debate ends up being about data. And it's if your data is bad, your AI is bad. And that's only partially true. So we realize that ethics issues, bias issues, and fairness issues really can happen anywhere in the system. From the data, of course, the data is a huge part of it, but it's not the only part of it. Through the model design, through how it's executed, through how it's monitored, through how privacy is maintained, through how security of user data is maintained. And we realized that if the conversation was just about data bad, AI bad, that we're really, really missing a lot of very important things. So we want to really help the industry by driving what we believe are best practices around responsible AI. So we, and I give an example here is like, this is kind of the pipeline when you're building an AI system, defining the problem, constructing or preparing your data, building and training the model, deploying and iterating, that there's so many places here where things can go wrong and lead to unfair systems, lead to biased systems, or just lead to wrong systems. So this is the process that we follow as we're building out our models. And we want to share that with the community so that as you're building out your models, you can learn from our mistakes and you can learn from the best practices that we've come up with. So there's some tools that we've been releasing around that. TF privacy, I won't go into detail on that, but the whole idea is to understand how attacks can happen on models and so that you can analyze them and fix them. One of my personal favorites is the Model Card Toolkit, so you can automate transparency reporting. And this one is one that will help you really focus on your data and to understand where there may be biases in your data. Now, there are some places where it's obvious to spot a bias, like, as you can see on the bar charts here, where there's way more white people than anything else, or there's way more men than women, or way more men than any other gender. And these are easy to spot. The idea behind the Model Card Toolkit is that when intersections then happen in this data, that can lead to biases. that can generally be very difficult to spot, and our goal is to make that as easy for you as possible to spot so that you can cleanse your data and make sure that you have a fair data set. So this toolkit, the Responsible AI Toolkit we've released, you can see it on here, tensorflow.org/resources/responsible AI. We're really excited about it. I think we're continuing to drive it forward, and we're hoping that to get feedback from everybody to see if there's anything we can do to make it better. I find personally that I'm particularly excited by the fact that we're talking about this now, because in my opinion, bias, unfairness has always been with us. It's not unique to AI, but the AI conversation has brought bias, fairness, and ethics to the forefront, and that's a great thing. And I think we all have something to learn from this. I know we at Google, and I know I do, have something to learn from this, and we're hoping to build and grow a community. We're sharing what we've done, but would love your feedback about what works and what doesn't. And then finally, I've mentioned the community several times, and TensorFlow is an open source product. It's not something that we make any kind of money out of. While it says Google on my paycheck, I generally advocate TensorFlow and AI as something for the community so that we can all grow together. I don't have any kind of sales target or anything like that. I'm lucky in that regard. And part of our goal to do that is to, if we build a powerful AI community, then that rising tide will lift everybody. So we've been investing a lot in tools and in communities themselves. And just a few examples of that would be TensorBoard is a tool that you can use to analyze your model as it's training, analyze the data in your model, all of those kind of things. But we realize that often when people are sharing their models, either producing some results that they want to share at a conference, or if they have a bug and they need somebody to help debug it, they were taking screenshots of TensorBoard.dev, or they were describing things that they were seeing. And we realized, well, for the community's sake, what if we were able to put a hosted version of TensorBoard out there that you get a deep link for, and then you share that deep link, and now anybody can see these parameters of your model or of your training ecosystem, and they can either see your results and verify them, or if it was a bug, they can help you debug it, those kind of things. So we released that freely available to the community for you to use. And like, this was one tweet that made us all very happy, where this researcher was able to show, you know, the full pilot data that they have for model retraining, and be able to share that with a single link, instead of like pages and pages of documentation to say, do this, do this, do this, do that, download the data from here, train it like this in order to replicate the results. Things like that was, you know, a way to kind of reduce friction from the community in order to be able to like help the community grow and climb. Translation and localization, we realize that AI is a global phenomenon, but there's only relatively few of us actually working in the outreach of that. There's never enough, but the community is something that we've been able to work together with to translate our content to multiple languages. So guides, tutorials, documentation into multiple languages. Currently 13 languages with our source code. Some of the guides, tutorials, documentation was heavily focused on Asia with Japanese, Korean, and simplified Chinese. And I've personally been working on our video outreach, and we've added like 7 new languages to our video outreach so people can learn about TensorFlow and how to use TensorFlow in their local language. A few things that we've been doing with various communities around the world, various community events from Tokyo to Korea to Shanghai to Turkey, Melbourne, India. And these are just events that have been happening in the last few months. And these are independent community-run events that we've been helping out and trying to support. There are many of these going on around the world, so we're really encouraged by the community, and we're doing our best to help grow the community. And there's also TensorFlow user groups. We call them TFUGs, TFUGs, and not GST thugs. Sometimes I need to have this thing fixed. TFUG. There we go. Oh, close enough. So then the idea is like these are around the globe, again, grassroots communities run by non-Google folks to help grow AI and machine learning globally. The special interest groups, as you can see here, online groups for you to be able to learn about each of these particular technologies in TensorFlow, ask questions about them, and they're monitored by our engineering team who can help answer those questions. There's Google developer experts, and these are, we've got close to 170 of these globally. And these are people who don't work for us, but who are recognized as experts in our technologies, and we endorse them as such. And they can be a useful independent voice for you if you want to learn about our AI platform and you want to hear about it from somebody who doesn't work for us, that kind of thing. We've been doing a lot of work with the Black AI community and the social justice movement, and the things that have happened in the last couple of years that have made us realize that the Black AI community is definitely underprivileged. The Black AI community as a whole is definitely underprivileged. And there's a lot of things that I think we can do, and we can leverage the influence and power that we have to help them. So in the last 18 months or so, we've been doing a lot of work supporting the Black AI community, funding HBCUs, donating to Black in AI, providing scholarships and Coursera credits for the various training courses for people not just in the US, but globally who need them. Part of my personal mission is to widen access to AI education for everybody. A small part of this, of course, was supporting the Black community, but it also goes beyond the Black community and into anybody who's an underprivileged group, be that somebody who's just unemployed to somebody who lives in a country where the economy makes it too difficult and too expensive for them to get access to training, those types of things that we've been doing a lot of work in that space. So if you want to become a part of the AI community and you want to learn how to do these skills, where you live or how much money you have should be as little barrier as possible. I can't say it'll never be a zero barrier, but we're trying to reduce that barrier as much as we can. And one thing that we learned as a barrier that people were facing was getting jobs. And this was made difficult by the fact that employers were having a difficulty in understanding what skills they should be looking for in machine learning engineering developers. And as a result, we saw even crazy interview questions because the skills just weren't out there, even in employers. And if the employers don't know what they're looking for, it's hard for them to employ the right person. So we decided to launch this certificate in TensorFlow development, where we say, these are the skills that we did research, these are the skills that most employers that we found need, these are the skills that we need, and we're going to build an exam to test somebody on these skills. And it's 3 core things in machine learning, which are computer vision, natural language processing, and sequence modeling. And the idea behind this is that you pass an exam where you code a machine learning model that is trained on data that we'll provide you. We'll test that model, and if that model passes our tests, you pass the certificate, or if all of your models pass our test, you'll pass our certificate. And then as a result, we have a network of people, there's over 2,000 now globally, who've taken the certificate exam, which is great for them to build their career, but also importantly, it's great for employers who are looking for people to say, if I need somebody who knows how to code in computer vision, these people have been certified in it. And the goal was to try and bring these 2 communities together to build up like an ML in industry. And despite the COVID pandemic and despite like a lot of people losing their jobs, I'm already seeing an uptick in people being employed and in people changing careers to become employed in Google AI and ML. Even we've hired a few people ourselves who've come through this program. That type of thing. So strongly recommend it to get a chance to look at it. It's TensorFlow.org/certificate. And details about the stipends that I was talking about earlier on for widening access are on that site. So that's it for me from today. Thank you so much for attending and listening. I don't know if we have a facility to take any questions or anything like that, but if you do have any questions for me about this, you can reach me on Twitter. I'm just L Moroney, L-M-O-R-O-N-E-Y. I can't do it properly, but you can look me up. It's just my first name, L, my last name, Moroney on Twitter, and I'd be happy to answer any questions there. So with that, I'll just say thank you so much.
Hey, Laurence. Yeah, that was a terrific presentation. And yeah, we actually will be doing Q&A in just a moment.
Oh, cool.
But yeah, that was a phenomenal presentation. Great slide deck. It was, as someone who's used TensorFlow before, it's really kind of cool to see like what goes into it, like behind the scenes and like everything that exists around it, aside from just like a tool as a software developer or data scientist. So yeah, it's really kind of cool to see that there's a lot more than meets the eye with TensorFlow. And specifically, I thought that the work that you talked about being done to increase the accessibility of AI for underprivileged groups is very, very cool. That's like something I had no idea about, but I'm really glad it exists. And so that was like a really eye-opening topic you mentioned, and I'm glad you brought it up.
Oh, thank you. Thank you so much.
Yeah, of course.
It's one of those things that, like, there's always a barrier of entry to anything.
Yeah.
And we're doing our best to drive that barrier as low as we can. It would be awesome if it was zero, but I don't think it'll ever reach zero. But the lower we can drive it, then the more people who can use it, and then the more people can use it, the better it is for all of us.
Completely agree. Yeah, very well said. Okay, we're gonna jump into some questions here. So just like we did in our prep session, we're gonna throw up the banners on the screen, and I'll read them out for you, and everyone can see them. So starting off here, a question we have is, what is the advantage of eager execution over using computational graphs?
Great point. So great question. So the advantage to me of eager execution is that it's quick for you to code and debug it. It's much easier for you to spot bugs in your code. It's much easier for you to kind of do step-by-step debugging if you're using an IDE, that kind of thing with eager execution. It does come at a cost of performance. Computational graphs are typically a bit faster than eager execution. And often if you're really looking for that extra bit of performance, particularly if you're a researcher and you're trying to drive like maybe some kind of optimizations there, then it might be good to prototype in eager and then move over to graphs once you've figured out your model. But for the typical developer who just wants to build a model to solve a business problem, in many ways, I would say eager execution is definitely the way to go, because you can more rapidly iterate on your code.
Okay, awesome. Yeah, great answer. All right, so given that the word quantum is becoming more of a buzzword lately, and I think a lot of people don't fully understand what that means. And then when you take that and apply it to AI and ML, it's even harder to understand. So this question really touches on that, which is, can you elaborate on what it means to do machine learning in a quantum environment?
Yeah, I'll be perfectly honest. I'm still trying to figure it out for myself. So we have a quantum computing infrastructure that we built at Google that we believe is, best of breed. And what we have started to do is to provide a version of TensorFlow that runs on quantum. It's called TF Quantum. So that there may be some scenarios right now, very bleeding edge scenarios like in chemistry and quantum chemistry, where quantum computers are better for managing, doing stuff in these environments than traditional computers. And then the natural extension to that would be, well, what if you can do machine learning in these scenarios that that quantum computers are much more better suited for than traditional computers? And as a result, that's the idea behind TensorFlow Quantum. It's still very, very bleeding edge at the moment. I think for most scenarios, and quantum computing as a whole is very bleeding edge at the moment. So for most scenarios, there may not be any particular advantage of doing it in quantum. But as we understand quantum computers better, and as we start to find scenarios that work better on quantum computers, then being able to apply machine learning to that may be a really, really interesting and exciting thing. Right now, for most of us, myself included, we can simulate a quantum environment. So you can take a look at what it looks like to create code that runs in a quantum environment, which is a little bit different than ones that run in a traditional computing environment. So if you want to scale up on that, just check out TensorFlow.org/quantum, but it's still super early days yet.
Okay, awesome. Yeah, given how hard it is to answer quantum-related questions, that was a pretty solid answer.
Thank you.
Okay, great. Next up, so I think this is a reference to one of the slides you had in your deck, which is that in the add-on slide, there was a point cloud GIF of a human body. Could you expand on the features of this add-on a little bit more? Specifically, is there any compatibility for export to Autodesk software?
So the slide that I was showing with the point cloud of the human body rotating was really to talk about TF graphics. And as I was mentioning, where the idea is so that we can learn from 3D models of environments, or we can learn from depth charts of environments. So the idea behind that one is in computer vision, feature extraction is generally a two-dimensional thing. So if you're building a computer vision model to say recognize difference between a cat and a dog, one of the things about a cat is they have these distinct pointy ears on top of their head. But if you're learning from photographs, then you're learning from this aspect ratio for that. And if the cat turns its head, then it looks a little bit differently. But with 3D learning, now the idea is instead of extracting features in 2 dimensions and looking for these triangles, you could be actually extracting features in 3 dimensions and think about the shape of a cat's ear. So that was really the idea behind that point cloud that I was showing, was that being able to learn in 3-dimensional environments. So export to Autodesk, I don't know of any compatibility to export to Autodesk, but to be honest, the better and bigger part of that would be more import from Autodesk. where the idea is that if you have 3D models or if you have things that were built in Autodesk and you could use that as data to be able to train something. So for example, if you created a 3-dimensional model of a cat and you skinned that 3D model so that it's photorealistic, that might be a much better way for you to be able to train an AI to recognize a cat than putting a cat into a photo studio and taking pictures of it from lots of different angles so you could like extract features in 3 dimensions. Now then extrapolate that away from a cat, which is a trivial example, to the kind of things that you might have in a self-driving car. You know, what a person looks like from multiple angles, or what a traffic light might look like from multiple angles. Now it's really exciting that you can maybe use something like Autodesk to build a 3D model of a traffic light. And now you're not limited to the number of photos you could take. You could render that traffic light from a million different directions and use that to train a model in 3D. So now a car is much better at recognizing what a traffic light looks like. Those type of things is really the idea behind it.
Okay, wonderful. Next question here. What enticed you to host several Coursera courses, and what legacy or impact do you hope to leave in the AI scene or setting?
Well, it's way too early to talk about a legacy. I hopefully have a few more years left in me, but what enticed me to do it was, it's a great question. So what enticed me initially to do it was that I realized that AI was very difficult to learn. And that's really what brought me into the AI space at Google. I was working on different technologies at Google, and I was trying to learn AI, and I realized how difficult it was. And I realized it didn't need to be quite that difficult. It could be easier. And so I wanted to drive a training that would make it easier for people who are coders to learn how to do AI and not necessarily have to do all the complex mathematics before they could begin, because there was a kind of an element of gatekeeping there. And so then to be able to do that, to be able to create a syllabus around that was the first task. And then once we'd done that, to be able to scale that out in the best possible way was the next task. And I absolutely adored Coursera. I love Andrew Ng's courses on Coursera. So I reached out to Andrew and shared this statistic with him that I'm going to share with you. And there was a survey done that said there are 300,000 AI practitioners globally, about 100,000 in China, 100,000 in the US, and 100,000 in the rest of the world. But depending on what survey you look at, there's generally at least 30 million software developers globally. And it was like, if you could train 10% of those 30 million, that's 3 million, and that's 10 times the number of AI practitioners that we have today. So if we could come up with something that was aimed primarily at software developers to bring them into this community and scale that out, I think it could be a wonderful thing for the AI community. And Andrew agreed with me, and that's when the courses were born. And then Andrew and I kind of decided to teach those together, and we have a lot of fun with them. And so, like, that's our vision, is like, hey, if we can reach 10%, that's 3 million. We're at about 1 million now, and that we've taught through these platforms. I'm sure there's a lot more than that million learning through other platforms. But it shows to me that, if we want AI to succeed globally, software developers have to be core to that. And that was the goal behind this. And that's why we've done 12 courses now. And so the legacy or impact that I want to leave with the AI scene, if I ever leave the AI scene and go do something else, is really that, by having AI and machine learning to be as core a part of the developer's toolbox as databases or graphics are, then we could have AI and ML be normalized and commoditized. And as a result, we'll have it everywhere. And then we can really have a better world because of AI and ML, and not just have it be something that's in the ivory tower of researchers or a select few companies.
Okay, awesome. Yeah, that was a really good answer. I didn't realize there was that thought process about the kind of relationship between software developer community and the AI community, but that's really cool. Okay, I think we have one more question here before we cut things off, which is, what are some of the major challenges regarding AI development and ethics in the future, and how do you think we should go about solving them?
Okay, so two different things there, AI development and ethics. So the major challenge, I think, regarding AI development is keeping up with some of the amazing things that are coming out of research and keeping it accessible with some of the amazing things that are coming out of research. The stuff that I'm teaching now was, bleeding edge, state-of-the-art 5 years ago. And now it's reached the point where any software developer can do it. You don't need to be a researcher in a major company. but I see some of the things that are happening in research are accelerating. It's getting more and more amazing. And the challenge of being able to break that down out of like research that's understandable by only a few dozen people into lessons and code and samples that are understandable by millions is going to be a major challenge. And that's something that I'm kind of trying to get my head around and trying to keep up on. And that's a huge challenge. Then the next part is ethics that you asked. I think one of the biggest challenges around ethics, there's so many of them, but I think some of the biggest ones are really understanding and being able to be open-minded to see how the work that we do could possibly have ethical implications. That's part of the point of the toolkit that I was talking about in my presentation, to really help us to open our minds to be aware of some of the ethical challenges that we have. And I think to be open and civil in discussing these things is really, really important. I've seen ethical arguments and Twitter wars and all of these kind of things, and they're totally counterproductive. If we make a mistake in ethics, it's nice to have it pointed out, but it's also nice for us to be able to grow together and understand, what it is about things that we're doing that could have ethical issues. And the more powerful systems get, the more damaging an ethical bug might be. And so that's a challenge that we just have to always be cognizant of through every part of the life cycle. But again, I would reiterate what I said in my talk, and that was that ethics and bias issues have always been with us. It's great that AI has us talking about it, but I can go back and list countless examples of pre-AI software that have ethics and bias issues that are extremely damaging to some parts of the population. So it's not a new thing, but it is good that we're talking about it again, and let's focus on that as we go forward.
Okay, awesome. Yeah, I honestly, I really like the amount that ethics is coming up in conversation in these questions. Seems like everyone's really embracing the theme, and glad that everyone's getting a chance to talk about it on stage. So I believe that's it for questions. One thing that people are asking about over on Hopin in the chat is to receive your slide deck. It seems like I'm not the only one who thought it was pretty nifty looking. So maybe if you'd be able to share that over email afterwards, we could distribute that. Would that be all right, Laurence?
Sure. I'm not sure if I can share all the slides, but I'll get a version that I can share with you.
Okay, that would be awesome. I think everyone would really appreciate having that.
Okay, sounds good.
All right. Honestly, what a phenomenal way to finish off our speaker presentations for the first day. Terrific job, Laurence. Thank you very much for speaking at CUCAI today.
My pleasure. Thanks, and enjoy the rest of the conference.
Absolutely, will do.
All right. Take care.